Hello, good evening students. Yes. Hi Pratik, good evening. So coming towards today's class, I begin with the CPP question which most of you have attempted it wrong, and this particular question which is given is from the concept again activation energy. Students, the question is like this: the activation energy of a reaction can be determined from the slope of which of the following graphs? They have given 4 options: log of k by t versus t, log of k versus 1 by t, t divided by log of k versus 1 by t, and option D is log of k versus t. Students, to answer this question, you should know the different forms of Arrhenius equation. So this particular question, the solution, the answer is option B, and I am going to write the solution for this. Students, we know that log of k will be equal to log of A minus EA divided by 2.303 RT. So this is the equation, student. Student, little bit disturbance is there, okay, so please bear with it. This is the equation. Log of k will be equal to log A. So this is log of k will be equal to log A. I will just write log A here. Yes, log A minus A divided by 2.303 RT. Students, here plot a graph by taking log of k versus 1 by t. Here log of k versus 1 by t, we need to plot a graph. So if you plot a graph, you are going to get a slope with a negative deviation. So the answer is option B. We are going to plot a graph by taking log of k along y axis and inverse of temperature along x axis. So this is the correct answer is option B. Students, so to answer these type of questions, you should know the integrated equations. Which particular equation is used to plot the graph, that is very important. Okay. Coming back to today's goals for the class. Students, today I am going to again discuss about the problems, the application part. Again, the problems on activation energy. You know that many different formulas from which we can calculate activation energy, and also Arrhenius factor and few problems on the calculation of rate constant again. Students, in today's class, to begin with, if you want to solve the problem, the first and foremost thing is you should remember the formulas, different formulas you should know, which particular formula is used, that depends on the data what is given in the problem. Okay. So let us see, let us go through the problems, let us receive the data and let us see which particular equation is valid for us to solve a particular problem. Okay, students. So today's first question is the rate constant. The rate constant for the decomposition of hydrocarbon is 2.418 into 10 power minus 5 per second at 546 Kelvin. If the energy of activation is 179.9 kilojoules per mole, what will be the value of pre-exponential factor? Students, let us write the data first. See, when you are solving a problem, first thing is you should know the data what is given. So here the data which is given is rate constant. Rate constant is k here. So let us write the rate constant k which is given. It is the rate constant of decomposition of hydrocarbon, that is 2.418 into 10 power minus 5 per second. and the energy of activation they have given. So, energy of activation is 179.9 kilojoules per mole. What will be the value of pre-exponential factor? Students, pre-exponential factor is nothing but A, that is what we need to calculate. So, you should know which particular equation is used. You know that there are different forms of Arrhenius equation. I write the equation here which is required to solve this problem, that is log of k will be equal to log of A minus EA divided by 2.303 RT. So, this is the equation which is required to solve this particular problem. You can see, students, what is the data they have given. They have given the value of k, they have given the value of EA, they have given the value of R is the gas constant, you should know that 8.314, and temperature also they have given. So, this particular equation, let us rearrange this. I need to calculate the log of A, that is A I need to calculate. So, I can rearrange this as log of A will be equal to log of k plus EA divided by 2.303 RT. So, we have rearranged the equation in this form. Now, let us substitute. Log of A will be equal to log of k, that is log of k value is 2.418 into 10 power minus 5 plus EA is 179.9 divided by 2.303, R value is 8.314. So, 2 into 8.314 into temperature, what they have given, 546. So, I have substituted the data that is given. Now, this particular equation can be, if we simplify this, you are going to get log of A will be equal to, student, the entire data which I have given, which I have substituted in the equation, if you simplify this, you are going to get log A will be equal to 12.5924. We need to simplify this. So, 2.303 RT, students, I have written little bit down here, 2.303, R is 8.314, and the temperature here 546. Okay. So, now we need to calculate A. How we can calculate A, students, here? So, A will be equal to whatever the value we got, let us take the antilog for this. So, antilog of 12.5924. So, if you take the value of antilog, the answer which you are going to get is 3.912 into 10 power 12 per second. Students, so this is the final answer for this particular problem. So, answer is 3.912 into 10 power 12 seconds. Okay. Okay, students, coming to the problem number 2. The second problem is the decomposition of hydrocarbon follows the equation K is equal to, the decomposition of hydrocarbon follows the equation K is equal to 4.5 into 10 power 11 per second e to the power of minus 2800 K divided by T. Calculate energy of activation. Students, let us write the Arrhenius equation. From Arrhenius equation we have K will be equal to A, little bit yes, students, what is Arrhenius equation? Can anyone of you, can you guess which equation we can use? Arrhenius equation, K will be equal to A into e to the power of minus EA by 2.303 RT. So, this is the Arrhenius equation. Let us consider this as equation 1. And the given equation, let us compare that. The given equation is K will be equal to 4.5 into 10 power 11 into e to the power of minus 28000K by T. This is the equation 2. Students, now let us compare, just a minute. Yes. Students, here we can use another form of Arrhenius equation to solve this problem, which will be more simple compared to this. Let us write just K is equal to A into e to the power of minus EA by RT minus EA by RT. This equation is more appropriate here. So, now let us compare the equation 1, that is Arrhenius equation, with equation 2. When we compare equation 1 and 2, we can write minus EA divided by RT will be equal to, let us neglect this. So, minus EA by RT will be equal to minus 2800 divided by T. We can write like this, neglecting. So, now we can write, we need to calculate energy of activation. So, we know that T and T get cancels here. Energy of activation will be 2800 into R. What is R here? R is universal gas constant. Student, this particular equation becomes EA will be equal to 2800, that 28,000 divided multiplied by R. The value of R is 8.314. So, if you solve this, the final answer which you are going to get will be 232.79 kilojoules per mole. That will be the final answer, student, here. So, just you need to compare the given equation with Arrhenius equation. This is the answer for the second problem. Okay. Next. Problem number 3. The rate of reaction quadrupoles when the temperature changes from 293 Kelvin to 313 Kelvin. Okay. Calculate energy of activation assuming that it does not change with temperature. Students, can any one of you guess on which particular formula this problem has been asked? Here the rate of reaction quadrupoles. Any answer? What do you mean by quadrupoles here, students? Yes, can I get any message? The rate of reaction quadrupoles means what? Yes? Jayesh, the previous problem, it is just you need to write the Arrhenius equation and you need to compare that Arrhenius equation with the given equation. That is the only thing. And Pratik, it is 28,000. Oh, yes. Now, for this particular equation, let us, students, bear little bit disturbance is there. For this particular problem, the equation which we are going to follow is log of K2 by K1 will be equal to log of K2 by K1 will be, just a minute. Students, it is log of K2 divided by K1 will be equal to EA divided by 2.303 R into T2 minus T1 divided by T1 T2. So, this is the very good Smarnika, she has told the correct answer. It becomes 4 times. Very good. And Sheikh, yes, you also given the correct answer. Quadrupoles means it increases by 4 times. Students, and this is the particular formula which should be used for this problem. the rate of reaction quadrupoles. Here K2 by K1 we can take it as 4. So K2 by K1 we can take it as 4 because they have told in the problem the rate of the reaction quadrupoles. Now what we need to calculate? Energy of activation. So let us substitute the required data in the problem. So we can write log of 4 will be equal to EA divided by 2.303. What is the value of R, students? Come on, what is R? Yes, I expect the answer. What is R here? It is universal gas constant, that is 8.314. It is 8.314 into. So temperature here. T2 is 313 Kelvin minus T1 is 293 Kelvin divided by T1 T2, that is 313 into 293. So the data which they have given I have substituted in the problem. Very good. Indrajit, Sheikh, yes, it is 8.314. Very good. So now we need to calculate energy of activation. Students, log 4. What is the answer? How do you say it is log 4? How you calculate? Assume that you don't have any log book, but you need to calculate log 4. In your competitive examinations, nobody will give you the log book and all, but how you will take the value of log 4? Come on. Any answer for this? I want the value of log 4. So you need to calculate the value of log 4. How you are going to calculate? Assume that you don't have any calculator, scientific calculators, no log book. How you are going to take the value for log 4? Square of log 2. 1000. Okay. So here log 4 can be written as 2 log 2 will be equal to EA divided by 2.303 into 8.314, 313 minus 293 divided by 313 multiplied by 293. Okay. Students, on simplification we know that log of 2 is, what is the value of log of 2? It is 0.3010. Very good. So energy of activation I should calculate here. Energy of activation is log of 2 we should take. That is 2 log 2 is nothing but what is 2 log 2? Come on, any answer for this? I am expecting answer from your side, students. What is 2 log 2? Yes. So 2 log 2 is nothing but 2 into, what is the value of log 2? Sheikh has given the correct answer, it is 0.3010. That is the correct answer. So 2 multiplied by 0.3010 into, so what they have given, 19.147 into 91709 divided by 20. I have simplified. I am writing the final answer, student, here. You can later on check the correct answer. EA will be equal to 52.85 kilojoules per mole. Student, this is the final answer which you are supposed to get for this particular problem. Yes, you can simplify this. I am writing the final answer here. So you should calculate the energy of activation. Energy of activation which you are going to get the answers, it will be in the in joules, students, that you need to divide it by 1000. So you are going to get in kilojoules per mole. That is the final answer for this problem. Yes. Coming to the next problem. Here they have given the half-life for a radioactive decay of carbon 14 is 5730 years. An archaeological artifact contained wood that had only 80% of the 80% of carbon 14 found in living trees. Estimate the age of sample. So this is the question, student. I hope you are listening it. Little bit difference is there. Problem is there here. So bear with it. Okay. So coming to this problem, the off lifetime they have given. Off lifetime is, it is T off. So I can write T off. They have given 5730 years. So what we need to calculate here, we need to estimate the age of the sample, that is T we need to calculate. How we can solve this problem, student? It's a two-step problem, we should use two different formulas to calculate this problem. Any guess for this? Yes? Any guesses to solve this problem, students? So first you need to calculate the value of k. We know that k will be equal to 0.693 divided by T of. This is the formula from which we can calculate. Too simple. Come on, calculate, Dhruv. It is k will be equal to 0.693 by T of. Yes, k will be equal to 0.693 divided by T of is 5730. So what will be answer for this? It is 1.21 into 10 power minus 4. So first you need to calculate the value of k. Yes, Dhruv, what is the next step? You said it is too simple. Of course, calculation of rate constant. All of you have calculated the value of k. What is the next step here? I want to calculate the age of the sample. Yes, any answer for this? Any guess? Which formula? You can write, you can message the words, whether it's a rate constant for a first order formula, rate constant for say zero order. Which one we should use, which formula we can use here? Yes? Come on, I want little bit interaction, others. Yes? So I need to calculate the age of sample. Again, T will be equal to 2.303 divided by k. Very good. Dhruv, again you are correct. It is integrated law of first order equation. Very good. So T will be equal to 2.303 by k into log of initial concentration R naught by concentration at that particular time interval t. So here you know the value of k. So T will be equal to 2.303. The value of k is 1.214 into 10 power minus 4 into log of percent means what? Per 100. So initial concentration will be 100 and at the time interval t, the concentration they have given it is 80%. Come on, I want the answer. Any one of you calculate it fast and tell me the answer. I will give you just 10 seconds for it. Come on. So T will be equal to 2.303 1 by 21 into 10 power minus 4 log of 100 by 80. Yes, I am expecting the correct answer here. Fast. No. So I will tell you the final answer. It is 1845 years. So this is the final answer here. So what we have done here in this problem? First we have calculated the value of k. After finding the value of k, we have calculated t. T is nothing but, yes Raghu, it is 1845. Very good. So that will be the final answer. You can check out for the correct answer. That is the answer. Yes. Students, now it is the time for the previous contest question. Student, the question is like this. On what factor the activity of catalyst depends? Here they have given the 4 options: on the strength of chemical adsorption, on the concentration of products, on the concentration of reactants, on the physical state of the catalyst. We know that the activity of catalyst depends on its surface area. So catalyst, if large surface area is available, then the rate of the reaction becomes more. But here they have not given the surface area. You need to pick the other answer which is very close to it. We know that in chemical adsorption rate increases with increase in the surface area of the catalyst. So here the activity of catalyst depends on the strength of the chemical adsorption. So that is the correct answer for this particular question. So this question correctly answered by Hemant. Congratulations Hemant, you will get 1 autumn session free. Very good, keep it up. Students, now today's contest question. The question is like this: the rate of reaction is equal to the rate constant. The rate of reaction is equal to the rate constant. Then the order of the reaction is, they have given 4 option. It is 0, 1, 2, 3. So this is the contest question for today's class. Okay then, I hope this easily you can answer this. I have given a shortcut in my regular class. Apply. Let us see in the next class. Okay, coming to the I think some of the students here, yeah, they are trying to answer it. Okay, let us see. Next is coming to the problem number 5. Sucrose decomposes in acidic solution into glucose and fructose according to the first order rate law with half-life time 3 hours. What fraction of the sucrose remain after 8 hours? You need to calculate what fraction of the sucrose remains after 8 hours. Students, what is the formula again here? The problem is based on the first order rate equation. K will be equal to 2.303 divided by T into log of R naught by RT. So, this is the equation. Students, what we need to calculate here, that is very important. We need to calculate the fraction of the sample of sucrose remaining after 8 hours. That is, we need to calculate RT divided by R naught. This is our calculation. We need to calculate this because in the problem you can see what fraction of the sucrose remains after 8 hours. Students, here to calculate here we need to know about the rate constant. You check in the formula, they have not given the value of K. So, first you need to calculate the value of K here. What is the formula we are going to apply? Yes. So, the formula is, we know that K will be equal to 0.693 divided by T off. So, they have given the off lifetime. So, we are going to get K will be equal to 0.693 by 3. So, what is the answer here? It is 0.231 per hour, that is the unit. So, now we have calculated the value of K. After knowing the value of K, now we can calculate the fraction of sucrose remaining after 8 hours. That is the ratio of RT divided by R naught. Let us substitute the values in the formula, the first order rate equation. Yes. So, we know that first rate constant is, I am substituting the values, 0.231 will be equal to 2.303 divided by 8 into log of R naught by RT. Now, this equation can be written as, I am going to simplify, you can 0.231 multiplied by 8, you can rearrange this equation. So, if you simplify this, you are going to get log of R naught by RT will be equal to 0.8024. Students, if you simplify this particular equation which I have written, you will get log of R naught by RT which will be equal to 0.8024. But what we are supposed to calculate here? We need to calculate RT by R naught. So, again R naught by RT will be equal to antilog. You need to take antilog of the value which you are going to get, antilog of 0.8024 students. So, antilog of 0.8024, if you have log books with you, you can easily calculate here. So, I will write the answer, R naught by RT will be equal to antilog of 0.8024 is 6.345. This is the antilog value which I have written. But we know we don't need R naught by RT. What we need? We need the fraction of the sample that is available. So, just we can write this, RT divided by R naught will be equal to 1 divided by 6.345. If you write this, the final answer will be 0.158. This is the correct final answer, students. So, the problem is based on again the first order rate equation, but in different ways they can ask the problem. They may ask you to calculate the rate constant. They may ask you to calculate the time. They may ask you to calculate the initial concentration. So, depending upon the data, you should know how you should substitute the values and get the final answer. Okay then. Next question. The rate constant for a first order reaction is 60 per second. How much time will it twice to reduce the initial concentration of the reactant to 1/16th value? So, this is the problem they have given. Students, again here we can use the first order equation. We need to calculate time here. So, time t will be equal to, it is 2.303 divided by k into log of R naught by RT. So, the same formula we can use, but what is RT here? That is very important. Students, RT will be equal to R naught by 16. You know that here 1/16th value they have given. So, now let us substitute the values in the formula. We are going to get T will be equal to 2.303 by K. The rate constant they have given, students, in the problem, that is 60 into log of R naught divided by, what is RT here? It is again R naught divided by 16. Can any one of you calculate and tell me the answer? I will give you a few seconds here, just 10 seconds I will give the time. Come on, Deepak. Yes. Come on, Deepak. Anybody, can you tell me the correct answer? Yes. The correct answer for this formula is, you are going to get, again, on simplification we can write, with this will be equal to 2.303 divided by 60 into, so it is log of 16 you can write. So, this particular problem you will get the final answer, T will be equal to 2.303 divided by 60 into, we can write log 16 as 4 log 2. So, the final answer here is T will be equal to 2.303 divided by K into log of, that is 4 into, just a minute, here I don't need to write log again, I will erase the log. So, you can write, again you can write here, that is 4 into 0.3010. So, if you calculate again the rate constant here, sorry, the rate constant value here is, I will write 60. So, T will be equal to, the final answer which you are going to get is 4.62 into 10 power minus 2 seconds. This is the final answer for this problem. Okay. Coming to the next problem. The rate constant for the first order decomposition of hydrogen peroxide is given by the equation log of K will be equal to 14.2 minus 1 into 10 power minus 4 K divided by T. Calculate the energy of activation, rate constant, and its half-life period be 200 minutes. This is the problem which they have given. So, here which equation we need to follow, that is very important. It is a first order equation, decomposition of hydrogen peroxide. Let us write the equation, Arrhenius equation, student, in the different form. Log of K will be equal to log of A minus A divided by 2.303 RT. Let us consider this as equation 1. Let us write the given equation. It is log of K will be equal to 14.2 minus 1.0 into 10 power minus 4 divided by, so they have given T. Just a minute, I will rub this. I will write once again this. So, it is minus the energy of activation they have given, that is 1.0 into 10 power 4 divided by T. Let us consider this as equation 2, students. Now, let us compare equation 1 and 2. By comparing equation 1 and 2, we can write minus EA divided by 2.303 RT will be equal to minus 1.0 into 10 power 4 divided by T. Again, on further simplification, we can write energy of activation will be equal to 1 into 10 power 4 into 2.303 multiplied by 8.314. So, which will be equal to 19.1471 into 10 power 4, which will be equal to 191.47 kilojoules per mole. So, this is the final answer, students, the energy of activation. You can see that many formulas I am taking here. So, the concept is energy of activation. See, many formulas, using many formulas we are calculating the value of EA. Yes, you should know that. That is very important. See, concept, if you understand the concept, if you remember the equations, which equation to use according to the data, if you use that equation, you can solve the problem. Okay. Next, problem number 8. The rate constant of ethyl iodide, they have given the chemical equation. Ethyl iodide, decomposition of ethyl iodide they have given at 600 Kelvin is 1.60 into 10 power minus 5 per second. Its energy of activation is 209 kilojoules per mole. Calculate the rate constant of the reaction at 700 Kelvin. So, we need to calculate the value of K2. You know that the rate constant at 600 Kelvin we can take it as K1, whereas the rate constant at higher temperature, let us take it as K2. Again, we have Arrhenius equation, log of K2 minus log of K1. Instead of writing log of K2 by K1, I am writing that as log of K2 minus log of K1 will be equal to A divided by 2.303 R into 1 by T1 minus 1 by T2. So, we can write this equation. So, here we need to calculate K2, students. So, this equation can be written as log of K2 will be equal to, just send this towards right side, it becomes positive, log of K1 plus, we can write A divided by 2.303 R, we should write here 2.303 R into 1 by T1 minus 1 by T2. So, let us substitute the values in the problem. We should, that is log of K2 will be equal to, log of K1 is log of 1.6 into 10 power minus 5 plus energy of activation they have given 209 kilojoules. Let us keep it in joules, 209 000 divided by 2.303 into 8.314 T1 minus T2, that is 1 by 600 minus 1 by 700. So, we need to calculate this. Students, you are going to get, on simplification of this, you are going to get log of K2 will be equal to, that is minus 2.197 you are going to get. Log of K2 will be equal to minus 2.197 you are going to get. So, or K2 will be equal to antilog of that. Antilog of 2.197. So, K2 antilog of that will be 6.30 into 10 power minus 3 per second. So, this is the correct answer here. The value of rate constant at higher temperature, that is K2. So, this is the correct answer for the problem, students. Okay. So, with this I conclude the problem section of today's class. Let us just summarize what we have done. So, in today's class we have done the problems on energy of activation. Students, there are 3 important equations and we have used those 3 important equations to calculate the energy of activation. So, all the 3 important equations are very important. I told you once again, depending upon the data, we should know which problem we need to, which formula we need to substitute. And of course, we have solved the problem on the Arrhenius factor and rate constant value K. Then, okay students, in today's again I have given 10 questions, that is CPP questions. So, based on whatever we have discussed in chemical kinetics until now, so make a list of all the formulas which we have come across in this particular chapter and see the data, read the question 1 or 2 times and see how you can solve which particular formula you can use so that you can get the correct answer, students. Okay, I wish you all the best to study well and try to answer all the questions correctly. Thank you, students. ಬರ್ತಾ ಇರುತ್ತೆ ಮತ್ತೆ ಅದು ಅಲ್ಲಿ